All right, class, welcome to section 7.4, the last conic section, and we'll discuss parabolas. Well, the parabolas that we're discussing are really the same parabolas we discussed in chapter, I forget now, 3, I believe, when we talked about quadratic functions and the shape of the graph of a quadratic function being a parabola. However, as you might see from the pictures down below, we will now look at parabolas that can also be oriented left and right. So, of course, if a parabola is opening up or down, that creates a function as it does pass the vertical line test. So these are going to be our usual quadratic functions with a little twist. If the parabolas are oriented left and right, then of course the equations of these parabolas will not describe a function as they do not pass the vertical line test. Either way, what we want to do is graph and look at feature of these types of equations in x and y, as again, they have many applications in nature. So, a parabola is the collection of all points at an equal distance from a given point, which we're going to call the vertex, and a given line, which we're going to call the directrix. Okay, so here we go. We're starting with a line and with a point. Okay, the given point that we're starting with, it's called the focus. The vertex will be halfway between. So we're starting with a given point, which is the focus, and the directrix. And we want to find all the points that are at the same distance from this given point, the focus, and this given line. Now, of course, the one that makes most sense is the one that kind of feels like it's closest to both of them, which is the vertex of the parabola. But from any other point on the parabola, if you draw the distance to the directrix and the distance to the focus, those distances are going to be the same. Okay, so there you go. From here to there measured, here to there measured, those distances equal to each other. Now, if you look at this little distance here in the middle, from the vertex to either the focus or the directrix, that distance is called the focal distance. Focal distance. And it's going to be extremely important in the equations we're going to describe. We call that distance p. So all the way from here to here is a little p, and all the way from here to here is a little p. Okay, let me take the rest of it away. Okay, so that's what a parabola is. Now, let's see what else does a parabola come. So, of course, we know about the vertex of a parabola. It's the same vertex that we discussed, as I said, back in chapter 3. Now we know that there's a focus inside that parabola somewhere. There's a directrix on the other side. Now, of course, same as with our other parabolas, a parabola is symmetrical, and there is such a thing called the axis of symmetry that goes exactly halfway through the parabola. In other words, we can fold the parabola over this axis of symmetry, and the two sides are going to fall exactly on top of each other. Okay. And then you see something else called latus rectum. And the latus rectum is the Latin name for simply straight line. And the distance, the property of this latus rectum, which is going to come up in the next problems, is that it's 2p on one side and 2p. So this distance from here to here is a total of 4p, where p is that focal distance. So if it's a p from the vertex to the focus, this distance here at the focus, the side that goes through the focus and crosses the two sides of the parabola. It's actually 4p long, and it's called the latus rectum. So the latus rectum, one more time, is this simple line that goes through the focus, and it touches the parabola. Okay, that's what the latus rectum is. So given that, I would like to now introduce the possible equations of a parabola. Now, of course, as before, we don't have a center for a parabola. There's no such thing as a center. The center is taken over by the vertex. So the vertex is kind of the central point of this whole story. So the vertex is, if you want to say, our center. So if we put that vertex in the origin, the equations, these are kind of funny looking. The equations of the parabolas are going to be y squared equals to 4px, where p is, again, that distance between the vertex and the focus, is that focal distance, okay? And then the 4p is, again, really the distance or the length of this latus rectum. That's kind of where that 4p is coming from. And so let me write these equations. X squared is equal to 4py. So as you see, we have two different types of equations for our parabolas, and it depends. So a parabola will only have either the x to be squared or the y to be squared. If you look back at the other three conic sections that we discussed, the circle, ellipse, and the hyperbola, both x and y were squared. For a parabola, only one of them is. Now, if x is the one that's being squared, then you get a regular quadratic function. Yes, f of x is something x squared plus something else, and so on and so on. So the point is y equals to x squared is our parabola. Yes. So if x is being squared, our parabolas are going to open either up or down. And of course, as you remember, when does a parabola open down? A parabola opens down if the coefficient of x squared is negative, right? If the a value that's in front of the x squared is a positive, then the parabola opens up. If it's negative, then the parabola opens down. So it's going to matter if, again, p is going to be a positive or it's going to be a negative. Okay, so we're going up or we're going down to find that focus. Now, if the equation of the parabola has y being squared, then you don't have a function. Y squared, that means you get two solutions for y on any x that you plug in. So therefore, if y is squared but not x, you don't get a function. So your parabolas are going to open sideways. And same thing, if p is a positive, then the focus is inside to the right. And if p is a negative, then you have to go in a negative direction from your vertex to the focus. And there's that. Now, of course, if the vertex, remember, the vertex takes the place of the center that we were having with the other conic sections. If the vertex is at some point of coordinates hk, then our two equations are going to change by subtracting this h and the k from your x and y. Now also be very careful. The x coordinate of the vertex always has to be subtracted from x. The y coordinate of the vertex always has to be subtracted from y. So again, if x is being squared, that means the parabola is going to open up or down. If y is the one that's being squared, then the parabola opens left or right. Okay. And there you have it. Okay. All right, so let's see how this comes into place. You just need that 4p. And so here it is. Now, I want you to be mindful, as again, I will give you these regular equations for the parabola, so don't worry about it on a test. So again, as you will see on your practice test, I will put the y squared equals 4p, x squared equals 4p y on the test. So you will see that the 4p always has to go to the side of the linear factor. So the squared factor is by itself, and then the 4p gets multiplied to the linear factor, the one that doesn't have the square, whether that's about x's or about y's. So here it is. Let's just get used to this. So this is in the perfect place. The number is on the side, or the coefficient's on the side of the x. So therefore, if I match this up to the kind of equation that I'm supposed to have, then 4p has to equal to 36. Therefore, p is equal to 9. Okay. So the focal distance is 9. All right, positive 9. Good. First thing that I need to find is where's the vertex. The fact that I have nothing subtracted from x and y, that means the vertex is going to be in the origin. And then I need to think about where will this parabola open? Left, up, down, right? Which way do I go? Well, the way we're going is going to be told by, depends on who's being squared. The fact that y is being squared, that means I do not have a function. So this parabola is going to open left or right. Okay. Since p is equal to 9, and I'm just going to go by threes because this is a little much. So in other words, this should be a 3, 6, and 9. So each of these units, I'm picking it to be 3 units. Okay. Because I won't have room. Okay, so here it is. Here's my parabola. The vertex is in the origin. Because p is 9, that means I have to move 9 units until I find my focus. So the focus is going to be to the right at 9, 0. Okay. Now I have to also be careful how, like, it has to be drawn to scale. So in other words, you don't just draw this because it's not going to be correct according to this equation. Yes, the shape is there. But next thing you need to know is that wherever you do, this latus rectum has to be 4 times this p. So let me show you. This tells me how wide the parabola is going to be. So from the focus, I'm going to go twice by this p up and twice by this p down. So this is how wide this parabola is going to open for us. Okay. So this latus rectum has a total distance of 36 units, so 4 times this p. Okay. So it says give the coordinates of the vertex, focus, the equations of the directrix, and the axis of symmetry. Okay. Now the directrix is the line opposite from the focus, and draw a line that's not going to cross. So therefore the directrix has equation, as you see, it's a vertical line, and that's x equals to -9. Remember, we're going by threes. So 9 units in the other direction to find the directrix. The axis of symmetry is the line that goes halfway through the parabola, and as you see, the axis of symmetry is, by the way, the x-axis, which has, being a horizontal line, has equation y equals 2, and that would be 0. So once we have that picture, it's really easy to read the features of this parabola. So let's try this again. Now, here it is. The coefficient has to be on the side of the linear factor. So y over -4, which definitely is going to be better looking if I write x squared is -1/4 times y. Okay. So that means the -1/4 stands in for 4p. So when I further divide this equation by 4 on both sides, I'm going to get -1/16. So the focal distance is -1/16. So this one was way too big at 9. This one's way too small at 1/16. I wouldn't even be able to draw 1/16. That's probably already more like 1/8, if any, or 1/5. So again, I'm going to make my scale a little bit to match whatever I have. So I'll go by 1/16. So I'm going to make 1 square of this a 1/16. Okay. Now let's see, where do we open this parabola? So first things first, the vertex, the vertex is in the origin. As you see, nothing is subtracted from x or y. And now the question is going to be, which way is this parabola oriented? Well, because x is squared, it looks like a quadratic function. Y equals something x squared. And so therefore, it's going to open either up or down. So I'm going in those directions. The fact that p is a negative, I have to go down, right? So here it is from the vertex. I'm going to go 1/16 down to find my focus. And then this width at the focus is 4 times this 1/16. So the focus is down on the y-axis, and we had to go down by 1/16. All right. So again, the distance from the vertex to the focus, this p-value, that is 1/16. Okay. Now, to find the directrix, same thing. The directrix is in the opposite direction by 1/16. And as you see, now it's a horizontal line. And the equation of that horizontal line is y equals to 1/16. The axis of symmetry is a vertical line this time, crossing halfway through the parabola, and the vertical line, being the y-axis, has equation x equals to 0. All right. So let's take those parabolas off the origin. So first of all, before I start counting in any direction, let's figure out where the vertex is. Now again, do not grab the first number you see. The x-coordinate of the vertex goes with x. The y-coordinate of the vertex goes with y. So this is where the vertex is going to be. That's where I start this parabola, the story. Now, as you see, the coefficient, the number, extra number, is with the linear factor, so it's in the right place. Now, I just have to match it. -4 is in the place of where the 4p has to be, right? So this coefficient, the number that has to be multiplied on the linear side, linear means power of one side, stands in for 4p. So therefore, easily, p is going to equal to -1. All right. So now I have to think of a couple things. Which direction is this going to open? Up and down, right? Left or right? And then in which way am I going to go? So again, since y is the one that's being squared, this is not going to be a function, so it's going to open left or right. And since this p is negative, I'm going to go in a negative direction. Okay. So I'm going to go in a -1 unit direction, okay, to find the focus. And then again, the width of the parabola at that focus is 4 times this. So there it is. Okay, there's the parabola. Okay, so 4 units. You don't need to draw that, but I'm showing you. That's the latus rectum. We need the equation of the focus, okay? And now that I have a pretty picture, I can tell where the focus is. It's going to be at -4, 4. That's simply because from -3, we had to go down 1 unit, and you could also read it off the graph. The equation of the directrix is on the opposite side of the focus. And as you see, the directrix is a vertical line again, and that's at -2. And the axis of symmetry is the line that goes halfway through the parabola. And as you see, it's a horizontal line, so therefore y equals 2, and that would be 4. Done. All right, and you guys try this. Think your way through. Start with the vertex. And again, I hope you've paused this video and tried and now come back. 8 stands for 4p, therefore p is equal to 2. X is the one being squared, so it's a quadratic function. That means it opens up and down. And because p is positive, I'm going to go up by 2 units to find the focus. And then this is twice as large, so 2, 4, and 2, 4 for a total of 8 units across. And there's the parabola. Okay, so the focus, as you see, has coordinates 1, 4, 2 units up from this 2. The directrix will have to go down in the opposite direction, and then again, draw a line that you're going to. Again, don't draw vertically, right? That's just going to be the axis of symmetry, the crossing through the parabola. So it gets to go sideways. So therefore, the directrix, as you see, is a horizontal line of equation y equals 2, and I see it 0. And the axis of symmetry is the line that goes halfway through the parabola, and that I see is a vertical line. So its equation is x equals to -1. I'm sorry, +1. So what I want to point out also is that by now we have discussed about vertical and horizontal lines so many times, not only since chapter 2, where we talked about lines and we've sketched them, but they kept coming back as asymptotes, axis of symmetry, well, now directrix. So again, hopefully by now you do know that every vertical line has equation y equals, as all the y's are the same on a horizontal line, and every vertical line has equation x equals, as all x's are the same on a vertical line. All right, now let's go backwards. And that's it. Find the equation of a parabola with vertex at 0, 0. So again, It's we did with the other conic sections, even though they didn't say graph it first. Without a picture, you cannot figure out the answer. Okay. The focus is at x is -4, 0. So to find the focus, we had to go left by 4 units. And the fact that the directrix has equation x equals to 4 is a bit redundant, as of course the directrix is going to be on the opposite side of the focus, so we really don't need this information. Okay. All right, so first things first, only one of these variables is going to be squared. So the question is, who's going to be the squared one? The fact that this parabola opens sideways, it means it's not a function, so y is being squared and x is not. Now, the other thing, as you see, we have nothing to subtract from x or y, as the vertex is 0, 0. So we have a y minus 0 and an x minus 0. And in front of x, we'll have to put 4 times p, where p is this focal distance. So the fact that we had to go down by 4 units, and shouldn't really say focal distance. I should say the absolute value of p is the focal distance, because a distance should always be a positive quantity. So let me make that clear. The distance is the absolute value of p. P can be positive or negative, right? It will tell us which direction to go to. All right, let's do this again. So the vertex is at 1, 2. The focus is at 1 and 1/3. Okay. And of course the directrix is somewhere else. I don't really care. The fact, again, the directrix, yes, is a horizontal line. Y equals 2 on the other side by the same many units up. Okay. So let's pick this. Again, number 1, who is going to be squared? Is it x that's going to be squared, or is it y that's going to be squared? The fact that this opens up and down, therefore it looks like a quadratic function, that means x is the one that's going to be squared and y is not. Now this time the vertex is not at 0, 0, so there are things to subtract from x and y. Yes, so we subtract 1 from x and 2 from y. Okay. And then same thing here in front, we need that 4 times p, okay? P is how much do we have to travel from V to F. So let's see, I had to go from 2 down to 1/3. So 2 minus 1/3 is 6/3 minus 1/3 is 5/3. So we had to go down by 5/3. And so therefore, P is going to be a negative 5/3. So that's what I'm going to plug in there. Where do I write that? I'll just erase it. So 4 times negative 5/3 is negative 20/3, by the way. Okay. All right. So again, from here to there is 1 2/3, yes, which is 5/3. Okay. And then if you go in 1 2/3 in the opposite direction, you will find the directrix at 11/3. All right, find the equation of a parabola. Again, the vertex is back nicely at 0, 0. But the endpoints of the lattice rectum, in other words, the straight line, are at 2, 1. That's interesting. and negative 2, 1. So here we go. These are the endpoints of the lattice rectum. That means your parabola would open this way, right? Oh, that's easy. Again, x is the one that's being squared. Y is not. It's a quadratic function. Looks like a quadratic function graph, right? A parabola that opens up. So the fact that vertex is at 0, 0, there's nothing to subtract from x and y. And then, as you see, the focal distance is 1. So 4 times 1, that's 4. And also, as you could tell, that whole distance left to right is 4 units, right? From negative 2 to positive 2. And that's it. And that's how easy it is. Okay, let's read this last one. It says an arch is in the shape of a parabola. It has a span of 100 feet and a maximum height of 20 feet. Find the equation of the parabola and determine the height of the arch 40 feet from the center. Okay, so the question is, how do I best place? Of course, this is going to be 100 feet. The maximum height is 20 feet. So I need to find the equation of this parabola. Now, I'd say the best thing to do is to place that vertex in the origin, right? Now, if I place the vertex in the origin, the way this looks like is just going to be a downward looking parabola. So definitely x is being squared and y is not. The fact that I put the vertex in the origin, there's nothing to subtract. And then I just need to figure out that p-value that I'm going to go by. Now, we know the maximum height is 20 feet, yes? Well, therefore, since I went down, right, this is a downward-looking parabola, I'm going to make that p I have to make the p a negative 20 because my parabola opens down. So x squared is negative 80y. Okay, so that's the equation of this parabola I drew for you. Then it says, determine the height of the arch 40 feet from the center. Okay. Oh, wait a minute. That's not correct. That doesn't mean the focus is here. We don't know where the focus is. Okay, we do have to find it. That would have been definitely a common mistake to assume that the focus is right at the end of that arch, but that's not true. So what do I have to do? I have to find the p-value, and then I have to, therefore, obviously what got me alerted is that, yes, the maximum height is 20 feet, but I didn't use the 100 feet, yes? So the fact that this is 100 feet across, that means up to here, whoops, is going to be 50. Oh, come on. Up to here is going to be 50. And down to here is going to be negative 20. So the point of coordinates 50, negative 20 is on this parabola. So in place of x, I'm going to put in a 50. In place of y, I'm going to put a negative 20. And that's going to get me my 4p. So 4p divided by negative 20 both sides. That's going to be a negative 125. So you don't need to actually solve for p. 4p is enough. So therefore the equation is x squared is equal to negative 125 times y, right? So you don't necessarily need to solve for p to divide by 4 just to multiply right back. So the 4p is negative 125. Okay, and now that we have the true equation of the parabola, again, it would have been, and I made that mistake too, to just assume that the focus is at that crossing point, but it's not, right? The focus has to be at the point where the distance left and right is 4 times the distance to the focus, right? Okay, so it says determine the height of the arch 40 feet from the center. So when you're 40 feet from the center, we want to know this distance from this height of the arch. So be very careful. I could figure out what the y coordinate 40 feet from the center is going to be. So if x is 40, what is the y value that I get to it? So that's 1600. So to solve for y, I'm going to divide by negative 125. So let me see what I'll get. That's going to be a negative 12.8. So that means this here is at negative 12.8. Now to find the height of this arch, I need to know how much is it from negative 20 up to negative 12.8. So the actual height of the parabola is 20 minus 12.8. So that's going to be a 7.2 feet. So that's really pretty and really interesting to find. So again, these equations do help, but they help not at all if we don't have a picture in front of us to understand what it is we're talking about, right? So it's pretty cool. Call this analytical geometry, as it is geometry, right? We're talking about shapes, but it's called analytical geometry as we're using algebra, right? Graphs, x's and y's, right? And equations to figure out distances, right? To figure out parts of these geometrical shapes. Now, I do want to mention one more thing. We haven't used our graphing calculators. And the reason why we haven't used our graphing calculators in this chapter is because to use a graphing calculator, you can only place a y equals equation. So it has to say y equals. Now, you can graph all these equations, but you have to solve for y, which can be quite difficult at times, yes? So you can always verify your answers, but again, it's not that easy. So you can't quite use, okay, fine. If you look at this equation right here, it is solved for y, so you could have graphed this and see what it looks like. But again, otherwise, it might take a while, and then of course, remember, if y is being squared, then you have to square root, put a plus or minus, and therefore graph two separate equations, okay? However, I have this ready for you. In Desmos, you can type in equations. You don't have to have it solved for y to graph these functions, right? So I took one of them that we graphed earlier, and I already pre-graphed it for you, this y minus 4 squared, and so on and so on. So I've put it in Desmos, I've typed it in, and here it is. As you see, the vertex is at negative 3, positive 4. It opens left. You can tell also from the graph, again, if I point these out, maybe what the endpoints of this, some of the more exact points on this graph you can look at. But what I'm saying is you can type any equation. Of course, this one is going to be a circle. Yes, x squared plus y squared equals to 4 is a circle with radius 2. As you see, boom, there it is. So you don't need to have these equations solved for y in order to graph with Desmos. So you can check your answers easily. Any hyperbola, anything like this, just type the equation in Desmos as it is, and you can verify your answers with that. Graphing calculators a little tricky, as you have to have them solved for y. All right, so we're done.